Hi, everybody. My name is Rachel Rayner, and I am part of the marketing team with BlueBotics, which is part of the ZAPI group of companies. I would like to welcome everyone to the session. Good morning, good afternoon. We are speaking today about fully integrated automation, ZAPI group solutions for AGVs and AMRs.
This presentation is to give an overview about what ZAPI Group can provide in terms of solutions to automate vehicles. As you know, ZAPI Group is, of course, one of the world leaders in the electrification of the vehicles. On top of that, we have an important part of the group that is able to do let's say, the next step, which is the automation of the vehicles. And this is indeed the goal that we have in the group, where we have, of course, many different suppliers, so we will see later on, and also BlueBotics, the company I'm working for, that is specialized in the navigation part. So our goal is to help you enter into this automation world and be able to automate a vehicle successfully for the market. In terms of key benefits, the idea is that when you automate a vehicle, you need many different components. Also, you will need some motors, of course, which are the same that you need for electrification. You need motor drives. You need, let's say, many different components that are part of the portfolio ZAPI Group can deliver to you. I can hear you, but you're behind off stage, so I think that someone has to put you on stage. So I'm now still presenting the part of Luca. That's why I'm a bit unstructured in the discussion. You are on stage, Luca, so I give it to you.
Thanks. Sorry, guys, for this problem. As always, technology doesn't help me too much. Good. So I think you already understand why ZAPI Group is the correct partner. You are just started to discuss the key benefit. And again, let me restart on the first one, the flexible comprehensive. For sure, when we need multiple components to realize our vehicle, and this component is supplied from different suppliers, we are going to increase the risk and complexity of the vehicle. For sure, to realize an AGV vehicle, it's already a complex project, and if it's possible, we don't want to add an extra risk or extra complexity. In this case, the advantage with ZAPI Group is that we have a very huge portfolio of component solution, and I want also to say know-how, and we can support to obtain and put together, connected many of these components. For sure, we can prove the technology to mix and realize all AGV EMR project, or we can say also ALGF, no matter, but we are sure to have the components suitable for your vehicle. I just ask you, Nicola, the pleasure to go on the next one. Thank you. Another important key benefit is the pre-configured. I mean, it's not enough to have just component coming from the same supplier. It's an important benefit when this component is already pre-configured, is already integrated. Because in this way, we remove risk, we remove waste of time. Let's just make a stupid example. When we have a navigation system that has to communicate with an inverter, if the two component is already pre-configured, we don't need to pay attention about CAN protocol or communication in general. It's we can use our time to be focused on other topics. And this is another advantage of ZAPI Group, because you can take more component and the component is already pre-configured or pre-tuned. What does it mean? I take navigation and inverter, okay, communication is already done. I take inverter and motor, okay, we know how to characterize the motor. I have a mixed fleet and I need a system for the anti-collision or telematics to put in the same ecosystem manual vehicle and automated one. We have also this solution that is already integrated. And next slide. Thank you, Nicola. By the way, ZAPI Group is not composed, does not offer, let me say, only component on solution. We have also our experience. ZAPI Group is composed by people, a lot of technical people with a huge experience. So can you imagine when you have to realize your first AGV vehicle, if you have the possibility to have a team of experts close to you, always available to support, to share know-how, and also sometimes to help you to avoid some mistake. And this is one of our important feature. We have a mindset that is customer oriented. So we want to offer our support, especially thinking to BlueBotics system. We have the 18 months support. For 18 months, you have get feel free support by our technician and to visit on site. And we believe that this is we can give all that you need. Correct me, Nicola, if I say something wrong.
That's all correct.
Perfect. So this is just a spot, some high-level information why we believe that Zap can be the right partner for you. So we have the component, we have the solution, everything is already pre-configured and tuned, and we have the people. Nevertheless, I want always to remind that we are not jealous. So we are not the company that say if you take one component, you have to take all the ecosystem. We are here to support you to give what you want. And I think now probably I take too much time. Sorry for that, Nicola. I will hand over the stage to you to start to explain a little bit the solution that we have.
Yeah, thanks, Luca. So no, you're not taking too much time because you do a great work, and I will be faster. So in terms of solution, what does it mean? So we have the components, we have a need to solve. I mean, it's an application to automate. Now, how to automate it? Well, there are different vehicle types that exist, and you have to pick up the right vehicle type for the right application. And here you see some of the vehicle types. So you can have with fork, as you can see here on the left. You can have under ride, which means vehicles that go under a payload and lift the payload to move it around. You can have towing vehicles, so with cars in the back, or you can have a unit load, which is a vehicle where you put something on top. Depending on the application, you will choose the vehicle that is more suitable to automate. Then there is also a question of which kind of, let's say, in a technical word, we call it kinematics, but our marketing team forbids us to use the keyword kinematics, so we call it steering type. So you can have what is called a tricycle. A tricycle is indeed like the children toy tricycle, where you have two fixed wheels and you have a turning and traction wheel, which is ideal for certain type of movements, in general, big payloads and Ford vehicles, because of course it adapts very well to the shape of a Ford vehicle. You have a differential, which is the one on the bottom right, which is built up with two driving units that can set different speeds, and the difference in speed will result in a curve. These are the most used technologies in AMRs and AGVs. Then you have the car-like, which is basically similar to the tricycle, but a bit more complex because you have indeed four wheels, so you have two wheels that have to be steered. And normally it's done by having, like a car, two driving wheels and then two steering wheels. So one more motor, which would make Luca happy because he can sell more motors and drives. And finally, there are omnidirectional vehicles where here we have more motors that allow to have a kind of also lateral movement. So in this case, there is an increase of maneuverability because you can really drive not only in a typical movement, but in any direction. So more maneuverability in general, however, also more motor and more complexity. So one has to find the right trade-off between indeed choosing more maneuverability or choosing the most adapted steering type for the application. So this is a bit the overview of the different vehicle types and steering types one can have when it is about automating. Now, again, when we move from a manual vehicle to an automated one, what does it mean? Well, here we have components that are all the components that are available at the group level. So you have I don't know which order I should start. Let's start by the motors. Of course, you need motors to move a vehicle around. And you know that ZAPI Group is about electrical motors. When you have electrical motors, you need inverters that are basically controlling the motors and giving the right speed to the motors to do the movement you would like to do. You have then a battery. This is not sold by the group, but then what we sell are battery chargers. And on top of that, you can have also options that are usable for the manual vehicle, like anti-collision, which allows to detect things around and slow down the vehicle for safety, and telematics, which is more about having statistics on the usage of the vehicle to do preventive maintenance or just to have a control about how the vehicle is used. And going to the next level, you can have a fully automated vehicle with a navigation system. So this is a bit the overview of the components that the group can provide to move from, let's say, a vehicle that doesn't move without the motors to an electrified vehicle, then an electrified vehicle with more functionality like anti-collision and telematics, and finally to a completely automated vehicle. Talking about automation, what we provide within the group is the navigation system from BlueBotics called ANT, which is a funny acronym for Autonomous Navigation Technology. What is special about this solution is that it combines the fact that it is simple to use and easy to commission, so it allows really fast commissioning compared to other technology, because you do not need to change the environment to use it. So it's called natural navigation because it doesn't need a cable on the floor or tags, etc., etc. So this is a bit the starting point. But on top of that, the system provides software tools that make it really easier to do the commissioning. And this is fundamental because commissioning is a big part of the cost for the end customer when he wants to automate. So the quick commission is important. There are other companies providing quick commissioning, but there are not so many companies or groups that are able to provide quick commissioning and real, accurate, and repeatable results. If I think about 10, 15 years ago, accurate and repeatable was kind of standard because you had either the cable on the floor, the tape, or the triangulation, and all of those were very accurate, but they were quite unflexible and heavy to commission. Nowadays, we are a bit the contrary, where there are a lot of newcomers into the market, bringing new software, new ideas, etc. They do great things to do a demo, but then they struggle to have really consistent, repeatable system over time that work for not only for half an hour for the demo, but for days, weeks, months, years. That's really the combination of quick commissioning and accurate is quite rare. On top of that, today, what differentiates our value proposal compared to the rest of the world is that on top of what I just said before, uh, we provide a multi-brand fleet management system that allows really interoperability of different vehicles. So of all the vehicles using our technology, so this blue box that is the controller in the vehicle, but even interoperability of other vehicles thanks to the emerging standard VDA 5050, which is the standard that is not yet finalized, so still a bit of troubles to make it work when you do the job. But we support it on the fleet management level, so it's possible to add on top of the already automated, undriven automated vehicles, also VDA 5050 vehicles. And finally, we have added a few years ago also the support for GNSS, so the standard GNSS with high precision to go outdoor and allow really a completely seamless indoor and outdoor operation when automated with ZAPI and BlueBotics solutions. Then we have, together with Ubiquicom, also an interesting solution that is something that is requested more and more in the recent time, which is about making manual vehicles and automated vehicles work well together. It's quite interesting because, I mean, this problem exists since the beginning of the automated AGVs, automated vehicles, because as soon as you have one automated one, it will have to interact with the rest of the world. But the request itself is coming more and more, I would say, in the last 2 years. The impression I have is that in the past, the system were more separated. Maybe it was a small part that was automated and all the rest still manual, while today there is more and more mixed. So really operation that combines on the same space, both automated vehicle and manual vehicles. And this results in some challenges. The most typical example is a racking system with a dead end where you have the manual driver getting in to pick up a pallet, and then you have an automated vehicle that is not aware about where the manual vehicles are and enters the same hallway and blocks the manual driver. So both are blocks, and this creates delays and time waste, and therefore also money. By using what is called an RTLS system, so real-time location system, one can take the information about the position of the manual vehicle up to the level of the fleet management system. And as soon as you have this, then you can start doing smart things like sharing the information, both giving the information to the driver where the AGV is and vice versa, and avoiding indeed that they block each other, being this in the hallway of the racking system or anywhere else where there is not enough space. The other big challenge that is coming more and more is the manual driver not reacting fast enough about an AGV that is around and bumping into an AGV. The AGV itself has the safety, certified safety, so that's not a problem. It will stop, but the manual driver may not see a small unit load vehicle coming nearby. And that's where, again, the combination of both allows also to give the information back to the manual driver that will be able to realize that there is something around. And the interesting thing is that this can be done with several solutions that we provide in the group. One is the one from Ubiquicom that provides ultra-wideband real-time locating system. This is about putting some beacons in the environment that allows them to detect the beacon that will be on the vehicle and to therefore know where it is. By sharing this information with the fleet manager, one can make indeed create value for both the operation of the manual and the automated one. Or we can use also the what we call the hand locator at BlueBotics, which is a laser-based solution to measure the position, basically taking the same localization system that is on the OGV and putting it into the manual vehicle. The big difference between the two technologies, from a cost point of view, let's say, not from a technology point of view, technology I explained already, is that the cost of a beacon-based solution scales with the size of the environment, while the cost of a solution, which is on the vehicle scales, of course, with the number of vehicles. So we have no a priori with respect to which one you should use. One has to choose the best setup for the use case, which is, sorry, which will depend if you have a one single vehicle in a huge environment, you better take the one on the vehicle. And if you have a small environment with many vehicles, you better take the Ubiquicom solution. On top of knowing where the system is, you have also information on these manual vehicles about uh, asset tracking. So by knowing where the vehicle is, where it picks up a pallet, you can basically do the same as with automated one, knowing where a pallet has been moved from where to where, so that the warehouse management system is aware about the position of the assets. One can also use it as collision anti-collision system. This is especially true for the ultra-wideband solution of Ubiquicom, where you really have an active system detecting what's around. And by knowing where all assets is, you can, of course, also automate inventory management. Now it's me that was taking too much time. So now I give you back to you, Luca, for the motor controllers.
Thank you so much. Yeah, in ZAPI Group, we have two brands, ZAPI and InMotion, that provides motor controller. Um, it's important to start from the point that also here we have a wide range of portfolio component and also a huge experience. Let's think just that we start to produce inverter 51 years ago, and nowadays we produce 1 million inverter per year. So no matter the battery voltage, we have solution from 24 volt up to 900 volt and from 1.5 kilowatt up to 300 kilowatt. So we are pretty sure to be able or to have the components suitable for your vehicle. Moreover, all our components can manage the most common motor technology: asynchronous, permanent magnet internal, surface, brushless DC, reluctant synchronous. So it's not a problem from us, the technology of the motor. We are really flexible. An important feature that we developed in the last, I think, 5 years was the introduction of safety function, STO and SS1. STO is safety torque off and SS1 is safety stop 1. Both functionality are in performance level D, following the EN 13849. And this especially it's so important in AGV application because especially in Europe we need to be compliant to the 3691.4 that require specific performance level for the emergency brake. It requires performance level D, and this functionality can be used to be sure to stop the vehicle, or can be used to be sure to avoid to have current or torque into the motor. All our inverter are based on CAN bus communication, CAN open on J9031. We have the same protocol of all inverters. So this means that as soon as you start to work with one size, you already know how to manage all the other components. We have some auto-tuning functionality. I mean, one of the bad things is always to characterize the motor. The auto-tuning functionality will avoid to make some specific tests to characterize the motor, but it's an automated functionality where we try to extract this data directly from the motor. And the last but not the least, we have a standalone component to move just one motor, but also dual or integrated solution. Means to invert in the same case or inverter directly connected to the motor. The idea is always try to be flexible and also to try to be more compact as possible. One important information, just a remind, keep in mind that if you like BlueBotics and if you take ZAPI or InMotion, the communication is already done. So this means you have not to think, oh, how can these two systems can communicate? This again, another key benefit of the group. Let's go on the next one. Thank you. ZAPI Group produce a lot of electrical motor, more or less 400,000 motor per year. And we have a specific business unit dedicated on the production of the drive unit. And we know that drive unit is absolutely an important component in AGV. We have various models. We go from the vertical one to the horizontal or to the dual drive. And for each family, we have already different size. Just to give you an idea, the maximal payload accepted is up to 8,000 kilograms, and the maximal speed that our solution can reach is 3.3 meter per second. What is important to underline is that we know that on AGV application, the flexibility is really important. So it's pretty impossible to have just one component of stock suitable for all the vehicle. Every customer has a specific needs. Every customer require specific customization. So it's important to be flexible and in the same time to continue to guarantee the quality and the performance of the product. And this is one of the key point of Schamuller, because they can customize the drive unit as you wish, working on the motor, changing winding, or put one or two electrical brake on top, created extended shaft to connect some safety sensor, modify the fixing plate or modify the wheel. So we have the possibility to customize this solution, but keep in mind that Schamuller is IATF certified. So this means all our component produced are automotive certified. They follow a specific process, and this guarantee a very high quality level. Again, it's important, and this is important for us because we know that when you have some trouble on the field, it's a big pain, and we want to avoid that. Next component is the battery charger. Oh, I ask you, Nico, just to move forward one slide. Thank you so much. In this case, we have three companies, Delta Q, Zivan, and Stercom. Again, we have not a limitation about the power, because we have solution from 350 watt up to 80 kilowatt. And also as output voltage, we go from 24 up to 900 volt. Moreover, thanks to this free company and our historical experience, we have products suitable for different battery technology, lithium, lead acid, supercapacitor, and moreover, we collect a lot of BMS protocol. So I like to say that we are already today more or less compliant to all the BMS that are present on the market. We are compliant to all the battery. And let me say that if you are able to find a battery that is not yet introduced in our software as BMS communication, not a problem. We can customize our software, we can introduce the communication. Also in this case, the component is CAN-based, so can open on J9039. And probably the most important value of our product is the globally certification. So no matter where are you in the world, we are present with our sales and we have a huge quantity of certification. So we know that our product will be sold all around the world. And again, sorry, Nico, if I take too much time. I believe that now we talk probably too much about component. Let's see some solution, some real example.
Yes, and I step in just to give two examples of vehicles that have been automated with our, so electrified and automated with our technologies. So here, for example, we see a tagger. It's a kind of airport tagger, but it's used also for automotive application from the company, Spanish company Movo. And in this case, the vehicle indeed is a vehicle that can work both indoor and outdoor and can transport up to 25 tons. So let's say full load up to 25 tons. In this case, the drive unit is a base motor motor with ZAPI EPS for steering. Then the inverter is a dual ace next gen from ZAPI, and they are all connected by a can open with the BlueBotics Satellite Plus system. And again, using the fleet management I was referring to before, our unserver fleet management system, which allows, I repeat, to also make different vehicles working together. And talking about that, here's another example of a vehicle automated with our system where we have a ZAPI converter in it, the new generation, that are in a native way then connected with Canopy to the navigation system. It's a forklift, so Pramac is known not only for the MotoGP, for those that know MotoGP, I'm a big fan, but also for forklifts. They do a big amount of forklifts that they deliver around the world, and they have started automating their own forklifts kind of 2 years ago. Now having more and more traction on the market with these fully automated vehicles. They use ZAPI inverters in general, also for the manual ones, and they keep the same setup for the automated version. They have 3 different vehicles for this. Now, in terms of architecture, I let Luca explain the details because he's more technical than me.
Thank you. Yes, the first important thing is that this is just an example of an architecture of a tricycle, because we saw before an example, and now we want to give you an idea how our component can interact. So if you want to realize a similar solution, what you should have to do. So if we start from the drive unit, again, ZAPI Group can offer a vertical drive unit like this case. We need two inverter, one for steering to close the position loop, and one combined inverter for traction and pump application. If you look this schematic, you see that it's just enough to connect the CAN bus to BlueBotics. As we said before, the protocol is already implemented. So in this case, BlueBotics is the real brain of the vehicle, is the one that localize and navigate the vehicle in the space. And the two inverter is like a dummy component. So receive the set point and they do what BlueBotics require. For sure, for every AGV, it's important to have also some safety component. I'm thinking to the laser scanner that are the eyes of the vehicle that are used also for navigation, but they are also used for safety. And due to the fact that our vehicle has to be safety, we always suggest a safety PLC on the vehicle that is the real control of the safety of the machine. One of the advantage of our component is that, for example, you can connect directly the safety system to STOSS1 functionality. In this case, typical example is the vehicle is driving. The safety scanner identify an obstacle or identify people that jump in front of the vehicle. Safety PLC is informed and can directly act on the inverter to break the inverter or to stop the movement. This functionality we said before can be done in performance level D, that is enough to be compliant to the norm. But if this is not enough for you, you can always put in the line a global main contactor to completely remove the power. You're going to turn off the inverter. And the last but not the least is the charger. Again, it's more related probably to the battery and not to the vehicle, but you can get from us the full system. And this is a schematic of a simple tricycle full AGV. Now let's jump on the next slide that is a little bit more complex, but not too much. Here the idea is to do a car-like Ackerman hybrid vehicle. Hybrid for me means that can work manually and can work in automatic mode. So let's start from the manual part. You are going to connect directly the steering and the gas pedal to the inverter, because in the manual mode, let's say, the logic for all the movement is into the inverter. Thinking to a typical car application, we have a two traction motor, the differential one for the front left and one from the front right wheel, and one steering. As soon as my vehicle wants to move from manual to automatic mode, okay, also in this case, BlueBotics, that is again the brain of automatic mode, take the control, calculate the set point, and communicate via CAN what the inverter has to do. The inverter automatically stop to follow the manual command and start to follow the information coming from CAN. You will see a small difference compared to the previous functional scheme. We put in the middle the customer PLC as optional. So this is not mandatory. I mean, if you want, you can directly connect BlueBotics to the inverter if you want to realize this vehicle. But sometimes customer prefer to have a PLC in the middle. uh, this gives them more flexibility if in a second stage they want to change maybe inverter with a competitor, or they want to change the navigation, because the PLC works as a gateway between the two parts. About the safety of the system, the solution is pretty similar to the one that we saw before. We have always our safety scanner that is used to look around and for robotics to navigate, and a safety PLC. Like before, as soon as an obstacle jump in front of the vehicle, safety scanner identify that, communicate a safety PLC that can work directly on the inverter. Like before, if this is not enough to stop the vehicle in performance level D, because your risk analysis say we need something more, you are always allowed to put a global main contactor to remove the power. And like before, sorry if I take always as last point, a charger solution is always available. I hope to be not too much technical, to have not confused too much the guys connected in this moment.
Well, Steve, it is a mistake to avoid what you just did.
Let's see.
No. So now the idea is that we have presented to you, well, what is an automated vehicle, which kind of component you need for that, which kind of component ZAPI Group can provide. Now, question is, if I want to start automating a vehicle, what should I know, what should I do, or what should I avoid doing? And that's just a short discussion around this topic, where we have put together 5 statements that five, not six, a small mistake, no problem, about this. And the first one is, if you want to automate a vehicle, well, you have to keep in mind you are not automating a vehicle. The goal is to automate an application. So it's fundamental to know the application. Very, very basic ideas. What do you want to move? Is that a pallet? Is that a box? Is that what is the weight? At which level is that floor to floor? Is that a certain age? Depending on all these parameters, you will have to approach the application, the automation in another way. Is the floor completely flat or not? Is it wet? Is it dirty? In terms also of acceleration, in terms of which wheel, which drive, motor drive, etc. This will be different.
Yeah, I totally agree with you. I mean, when you have to select the right solution, it's important to start to have an overview at a very high level, to share, to discuss with your partner for to realize this vehicle, which is the final application. It's something that we always suggest to our customer to have an open discussion with us, to share which is the idea of the vehicle, where the vehicle has to work, because in this way we can also share our know-how and sometimes could share some good feedback in order to avoid mistake or to avoid loss of time, or we can propose some component that can be better. For example, if we want to do an application in a facility to move the Parmesan cheese, just because I'm Italian, say that, probably we need to keep in mind that component has to be in stainless material, or we need to pay attention to have an IP to avoid leakage of oil and so on. So it's important to start from a global overview about the application.
Yeah, that's really the key point. I remember when a long time ago, when we're talking about creating a new company, people will say that new company startups, there are two types of those. There are those that found a problem and they use technology to solve it. And there are those that have a fantastic technology, but they don't know what to do with it. So this point number one is about that. Please, when you automate a vehicle, don't do scenario number two. Try with scenario number one, decide what you want to solve and take the right components and the right system to make sure that you solve that problem. The second point, focusing on the wrong cost. It's become especially important in the last few years, where we see
Mm,
more and more companies hitting the market and proposing low cost solutions. Low cost is beautiful if it does the job. Low cost is not beautiful if it does not do the job. And this we see that some of the suppliers on the market now I think about vehicle makers, but then the components are basically the same. Huh? They provide something that is not working at the level that is expecting automation. Typical automation operation, we expect a success rate, so missions, let's say jobs to move stuff without any help of human. We expect in the past it was kind of 98% was enough. Now we are more than 99, and some customer even 99.5% of all the movements without any human intervention. That's the expectation of the market. So you find more and more suppliers that are getting to the market with lower cost, but they are far away from that. And far away is even just 95% is far away. We are aware about plants where the vehicles they do 13,000 movements per day. If you take 5% of 13,000, still it's more than 500 problems to be solved by a human. And this means that you're just shifting investment. Instead of investing in a good solution in the beginning, you will then have much more operational costs all the time, not only once. That's why this comes back also to the component. It's the same. In order to have a reliable automated vehicle that can do the job, you have to choose the right navigation, the right inverter, the right motor, etc., etc. I don't know, Luca, if you want to add something on that one.
I totally agree with you. I can also understand, let's say, when the customer has to realize the vehicle that for sure pay a lot of attention on the cost of the component. But I think in this case, it's really important to have a long-term overview because AGV is an investment. So we cannot think just to what we are paying today. We have to think that this vehicle will work for a lot of time. Uh, Here and in this time, this vehicle has always to work, as not to be blocked for some stupid issue. Uh, this is the correct application where we want to. I want to say that we don't have to be scared to pay the quality of the component.
Yeah, that's an important point. For those that maybe are not aware, a typical AGV system is expected to work minimum 10 years. And big difference also compared to manual vehicles, one has to be aware about that. The amount of hours that a manual vehicle work are much less than an AGV. Motors will be treated much better by an automated system because with an automated control, you do better than with the manual driver. But in terms of how long they are used, it's really much longer. So really fundamental to choose the right components in order to do the right vehicle of performance. So today for the automated vehicles, at least we think it's much better to go for let's say, top of the line components instead of trying to cut $50 there and 100 there and end up with having problems that will cost for every intervention the same amount.
Absolutely. If I think, sorry, if I add just another note, if I think in particular to the Schamuller drive unit in this moment, uh, you can understand probably right now why was important to specify that are automotive certified. So this means that when the product is produced, there is a very attention to have everything in line with the drawing. All the components are tested before it to be shipped, and we have always in the mindset that this component has to work 24/7. So this means that if we have to decide, we decide to have a little bit more iron or more steel in order to have a more robust component.
Absolutely. Now moving to the next point. So automating the wrong vehicle. Last week, both Luca and me were at the Modex, and I think I got at least two, if not three times, the same question, which was with end customers. How they were saying, we have I don't know 100 manual vehicles, and we would like to automate. Can we automate our vehicles that we have today? So the short answer is yes. However, in this case, is the very ugly answer, yes, but. And the yes, but comes from the fact that if you take the components of ZAPI group and you add the safety scanner, you can automate everything. However, the vehicles that are already in operation, they could on one side already be used. They could have motors that are not designed to work 24/7. And even more important, they may not be so much automation ready. Like, for example, do they have a motorized steering or is that a manual steering? Do we have an encoder on the steering to be able to control it or not? So again, everything is feasible, but it may cost more to try to automate an existing one than taking one that is automation ready adapted. Small comment here, interesting, is that especially the leader in material handling, so manual forklift, they tend to deliver more and more vehicles that are automation ready. So maybe in the future this may be more easy. For the moment, be careful about which kind of vehicle you want to automate.
Absolutely right. I think that probably to automate manual vehicle that already exists is probably the most critical project that we can do, because as you say, we are not always sure which was the component or the software or the layout present on the manual vehicle, because the scope was different from an AGV. And sometimes the easiest way is just to say to the customer, we can automatize, but the simple one is remove, maybe hold inverter, take a new one, or take a solution, as you say, that is already designed or thinking for an automated solution. Everything is possible, but it's important to understand how much trouble we want to face, how much we want to simplify our life.
Yeah. And now I see that we are getting a bit long, so maybe do you start, Luca, with the demanding crazy accuracy point?
Yes, so why not? This is for me always a funny request, because for sure accuracy it's important. But as we say in the point one, it's important to understand the application. Because if we need to automatize, I think a VNA that has to put a load at very high level, it's important to have a very good accuracy to stay to some millimeter. But if you have to realize a vehicle like the one that we saw before of Movo, that is used maybe to move some luggage, why do I need a millimeter of accuracy? Is it really a problem if my luggage stopped 1 centimeter more or 1 centimeter less? And this seems something so logic, but I know also the technician mentality, because I was in an R&D in my previous life, and we always try to push to have the best. We want always the best solution, the best precision, the best accuracy, and so on. But keep in mind that when you require a crazy accuracy that is not maybe necessary for your application, means that you are going to spend money, and probably you are going to create a really complex system when it's not necessary.
Yeah, that's very important. I think the key message here is really accuracy is a must, and especially repeatability, as we said in the beginning.
Yeah.
But keep in mind that the more you want, the more it will cost. And so to take the level that you need, otherwise you're wasting money. And even our statement is, especially, if you are working with an industrial robot, you can go to sub-millimeter precision. If you are working with an AGV, it's if you have a good system, you can get to the plus minus 1 centimeter. If you need more than that, our advice is think also about having mechanical guides. Luca, you were talking about the VNAs. When they go, let's say, on the horizontal movement, there are always guides on top of the system because you are
Absolutely.
going at speed. Instead of being completely crazy, you make the guides help the system. So finding also the right compromises, especially when you go to the limits of the accuracy to avoid having huge costs, as Luca was saying. And
Absolutely.
finally, I see, Luca, you are excited to go to the last point.
Not thinking to the system. I think we talk a lot about the system, but it's important to remind that when you approach an AGV, it's always important to, as we said before, start from the application, start from the whole vehicle, and if you can get support from one supplier to realize all the system, this can for sure simplify your life. Otherwise, let's think to the worst case. You take component from all different supplier. Okay, the first one is navigation can communicate with the inverter. Uh, if we are lucky, they have the same protocol. If we are not lucky, maybe one communicating, I don't know, Ethercat and the other in can open. And we start with the first problem. Does the inverter know how to tune this to manage correctly the motor? If coming from the same system, yes. Sometimes we saw that it's also complicated to obtain information from motor supplier. So, and it's another trouble. We need a safety system. Yes, for sure. I mean, we want a safety vehicle, but when we want a safety vehicle and we need a safety PLC, we need to uh, program the safety PLC. Are we available to do that? Have we all the information coming from the other components to have a safety machine? Um, what else? If I have to put my vehicle into an ecosystem, I have a fleet manager that can support or not. So, um, for sure, this I think this picture is perfectly. It's when you have to put together a lot of components, it's an headache problem, and it's more easy when you find a good partner that can give you a package that is already pre-integrated. And believe me, also with a package that is pre-integrated, I'm sure you will get some trouble to realize application, because realizing AGV is a complex vehicle. It's not rocket science, but it's a complex vehicle.
Yeah, and
Do you
then
agree?
if I can jump on that one, the key point is also about how you then, you as vehicle maker, how you interact with the suppliers. The advantage of having a package is that you know who to call. Basically, to be honest, I had a discussion. I don't know if it was Luke or someone else asking me, but what happens if an HEV is not working as planned? Do they call the supplier of the drive, or the inverter, or the motor? They always call the navigation supplier, because in the perception of the customer is, well, it's not moving as planned, so
Yep.
navigation is not working. Now, on our side, it's simple. When we deliver as a package, we have the full responsibility. And I know I can call Luca. It will help me to discuss with anyone in the group. It will be a fast interaction. With other components, of course, we have good relationship with them too, but it's another level. So that's really the advantage of thinking system. In general, one has to think system. So
Yep.
we, as navigation partner, we help no matter which component you take. But of course, if you take a package, it's a bit easier. And now I think we have to move to the summary, then to the end. So, well, the summary, I would say we did it there. We went through the AGV, the components, how that group can supply these components, and the error to avoid. Do we accept questions? How does it work, Rachel?
We only have a few minutes left, but I think we've got time for one or two questions. Again, I'd like to invite everyone to add your questions to the Q&A tab, which you'll see on the right of your screen. Now, the first I know was a very hot topic at Vodex, and you have touched on it briefly, but especially in larger mixed fleets, how is interoperability handled? How can we make the vehicles work together if they're from different suppliers or different brands of vehicles?
Who-
Oh yeah, that's indeed a quite hot topic. I take it, look, if it's okay with you. Um, let's say that there are three ways of doing this job. So we are talking about automated vehicles from different brands. There is I would call it the old way of doing that, which is a kind of, let's say, virtual traffic light or called also interlock. I define this as an old style in the sense that it's the only thing that was existing in the past, but still it makes sense. Huh? It's about when we share a space, simply the two controllers or the two fleet managers, they talk to each other. If you have a blue fleet and a green fleet, the blue fleet will say, hey, my vehicle has to go through this shared zone. Can I block it? The green will say, yes, please do it, and this will go. If it is simple crossing, it's even the most intelligent way of doing because it's really simple and it works. Now, if you have more overlap, then it gets more complicated. And in this case, there are two ways of solving the problem. One is, I will call it a future way, but it's still existing today, which is using standards. There are some standards that are coming. They are not finalized, so you can use them, but it still requires some struggle. The alternative is to work in ecosystems. If you take ZAPI, BlueBotics, we have, let's say, our ecosystem. There are more than 150 different vehicle types that use the same technology, and we have the ideal interface to these vehicles, and we can really have the interoperability defined, let's say, in a transparent way with high performance. We use the full functionality, and in this case, we can deliver more.
Fantastic. Thank you for that. And I have another question about the components come through as well. So, in more difficult environments, extreme temperatures, such as in cold stores, does ZAPI Group have components that would work in these extreme environments?
Yes, yes, for sure. Thanks for the question. And again, this is coming back to the previous slide. It's important when we start a discussion to explain where the vehicle has to be applied or the behavior condition. By the way, yes, we have some solutions. Some of our component is suitable to works on this type of environment. It's important during the development phase to specify in order to select the right part, but it's not a problem.
Fantastic. And unfortunately, I think that is all the time we have today. We're literally down to the last minute of the presentation. So thank you again to Luca and Nico for the session. And to all attendees, if you would like to download a certificate of attendance for continuing professional development, you can find that after the event if you've watched at least 75% of the broadcast time. They're available in the event lobby under the feed tab. And when you're in the lobby, would like to invite you to jump into another session. There's a panel of leadership and electrification, navigating global markets, innovation, and industry transformation, which starts at 5 p.m. European time, 1 hour from now, which I think looks really interesting. So again, thank you so much to Luca and Nico for your time today. And
Thank
we'll talk
you.
soon, everyone. Bye.
Bye. Thank you very much.
Bye, bye, bye. Thank you.